Hi students, welcome to Time. Okay, in this session, we will be discussing about the questions in reflection of light. Hope all of you have done the homework, whatever is given to you. Okay, the texture based questions, the skill builder questions also, I think you have done. Okay, I suggest you keep the books, whatever you have written the homework, the books in which you have written the homework. You keep those books in front of you, then follow the session so that you'll be able to compare the answers, whatever you have written. Okay, it may be right or wrong, doesn't matter. But now, as we discuss these questions, you will be able to know where you have gone wrong, if it has gone wrong somewhere. Okay, and even though it is right, you will be able to know why is it right. Okay. So let us begin our discussion with the first part of it, the texture basics. In that, again, we start with fill in the blanks. Let us see the first question. Lower limit of wavelength of visible light is 400 nanometer and the velocity of light in air is 3 into 10 power 8 meters per second. The upper limit of frequency of visible light would be. So what would be the upper limit of frequency of visible light? This is the question. Now, basically, this we will be able to solve when you consider light as an electromagnetic wave. Okay. The speed of the electromagnetic wave is given as 3 into 10 power 8 meters per second. V is equal to n lambda is the expression what we have. So, therefore, n is equal to V by lambda. What is lambda? Lambda is a wavelength. V is a speed. So, n is a frequency. Okay. So, given that for n is equal to V by lambda, if you want n to be maximum, the lambda should be minimum. Why? Because the value of V is constant in vacuum. That is given as 3 into 10 power 8 meters per second. Clear? So now we'll try to substitute. Given this is the 400 nanometer, nano means 10 power minus 9 meter. So I'll write that. And then I'll substitute the value of V as well as lambda in this particular expression to get the value of the frequency as 0.75 into 10 power 15. So if you put it in the proper significant digits, I'll get it as 7.5 into 10 power 14 hertz, which is a unit of frequency. So what should I write over here? Exactly, it is 7.5 into 10 power 4 hertz. Clear? Let us move on to the next question. Dash type of image is obtained when the light rays appear to meet. Appear to meet. You have to follow the question very carefully. Dash type of image is obtained when the light rays appear to meet. They are not meeting, they appear to meet. That means the light rays are diverging. So, what kind of image can be formed by the light rays which are diverging? Obviously, it's virtual images. Clear? Let us move on to the next question. Reflection in an uneven reflecting surface is irregular reflection because normals drawn to the uneven surfaces dash to each other. What is the dash? What you should write over here? If I consider an uneven surface like this, you can see these light rays are coming over here incident, okay, and they're getting reflected. We do have several points of incidence. What will I do? I will draw normal here, and normal at this point, and normal at this point. You can see these normals over here. Okay, are they parallel? The incident rays are parallel, but are the normals parallel? No. Because they are not parallel to each other, the reflected light beam, the light rays in the reflected beam are not parallel. That is the reason it is called as an irregular reflection. So what should I write over here? They're not parallel to each other. Simple. Clear? Let us move on to the next question. Magnification is dash for real images. What do you mean by real image? Which can be caught on a screen. And real images generally are inverted. Okay. So real image, whenever you talk about the real image is always inverted with respect to the object. Okay. With respect to the object, it is inverted. So they are negative. Clear? Let us move on to the next question. The mirror which produces virtual magnified image. Now recall the type of images found in spherical mirrors, concave and convex. Where can you find a virtual image? In both of them, right? Even if it is a convex mirror also, we can form virtual images. Even if it is concave mirror also, it can form virtual images. But the images he's talking about, virtual image he's talking about is magnified. So magnified virtual images found only in, yes, it is concave mirror. In the case of convex, the virtual images formed will be lesser in size compared to the size of the object. Clear? So they are called diminished image. Virtual magnified images are possible only in the case of concave mirrors. Clear? Let us move on to the next question. Here we have the multiple choice questions over here. Let us see the first one. Nature of the image produced by convex mirror. Virtual, real, inverted, both 2 and 3. Real, inverted, no question at all, right? So fourth choice is also ruled out because the mirror is convex. So convex mirror will always form virtual images. So this is the answer. Simple, isn't it? Let us move on to the next question. Parallel beam of light falls on dash mirror becomes a convergent beam after reflection. So actually we should not say false, it is incident. Okay. Parallel beam of light incident on dash mirror becomes a convergent beam after reflection. So which is the mirror that will converge the light rays after reflection? Yes, it is a convergent mirror. Which is the convergent mirror? It is the concave mirror which is the convergent mirror. It is not the plane mirror nor the convex mirror. Okay, the nature of the images formed in plane and convex mirror are virtual. Okay, clear? Next, if radius of curvature of a concave mirror is 20 centimeter, then its focal length is dash. 10 power minus 8 nanometer, 10 power 8 nanometer, 10 power minus 8 picometer, 10 power minus 5 micrometer. Basically, what is asked in the question? Focal length. What is for concave mirror? What is the relation between the radius of curvature of a concave mirror which is given as 20 centimeter and its focal length? Not only for a concave mirror, but for any spherical mirror, focal length is half the radius of curvature. Try to recall it, right? So when the radius of curvature is given as 20 centimeter, we will have the focal length as 10 centimeter. And which is the answer which gives us 10 centimeter over here? All are given as prefixes. SI prefixes are given over here. Nano. Nano refers to what? 10 power minus 9. 10 power minus 8 and 10 power minus 9 if you add, we will get it as 10 power minus 17 meter. Whereas the focal length is only 10 centimeter. 10 centimeter means 1/10 of a meter, which is nothing but 10 power minus 1 meter. So if we simplify the expressions over here, I should get 10 power minus 1 meter. Clear? So first one is ruled out. What about the second option? 10 power 8 nanometer. Nano is 10 power minus 9. So if you substitute the prefix over here, okay, in terms of 10 power, then I'll get 10 power 8 and 10 power minus 9. I'll get it as 10 power 8 minus 9, that is 10 power minus 1. Obviously, that's the answer what we require. Clear? So the correct option is 2. Now, let us look at the third and fourth option also, whether they are also giving the same option, same answer. Okay, 10 power minus 8 picometer. Okay, pico is what? 10 power minus 12. Here already I have 10 power minus 8. So minus 8 plus minus 12 is becoming minus 20. So 10 power minus 20 meter, this is not the answer. 10 power minus 5 micrometer. Micro refers to 10 power minus 6. So I'll get here 10 power minus 6 into 10 power minus 5 means 10 power minus 11 totally. Okay. Minus 10 power minus 11 meter, this is also ruled out. So finally the answer, as we mentioned, it is only second option. Clear? Next one. Magnification of a concave mirror when it produces virtual image is. Magnification of a concave mirror when it produces virtual image. When does a concave mirror produce a virtual image? Try to recall. Remember the shaving mirror? Yes. As a makeup mirror, whatever it is. Okay. You put very close to it, the face, right? That means the object is lying within the principal focus. Or you can say the object distance is less than the focal length. In such a case, you will get a magnified image which is behind the mirror. So it is a virtual image. Okay. It cannot be caught on a screen. So when you say it is magnified image, what will you call the magnification? Is it equal to 1? No. Is it less than 1? No. So it is greater than 1. Okay. So when I say greater than 1, yes. We will not have minus 1 here. Why? Because when you say measure the virtual image is lying above the principal axis. So it is taken as positive. Object is anyhow, the height of the object is anyhow a positive value. Now height of the image is also a positive value. So we will get it as greater than 1. Clear? Not minus 1 over here. Clear? Next one. If the angle of reflection is half the glancing angle of reflection, then the normal of incidence is dash. 30 degrees, 45 degrees, 60 degrees, none of these. What is given? If the angle of reflection is half the glancing angle of reflection. So he is talking about two angles over here. So if I take a mirror like this, I'll take a incident ray and getting a reflected ray over here, and I'll draw a normal. Now if you consider, let me just check out what we'll get. So now I can say this is the angle of incidence. This is the glancing angle of incidence. And this is the angle of reflection. And this is the glancing angle of reflection. Okay. So now he is giving the angle of reflection, this one R is equal to half of the glancing angle of reflection, half of GR. This is given. Okay, this is given for us. What is asked? Angle of incidence is equal to how much? Okay. Now R plus GR is equal to 90. I know it, right? R plus GR is equal to 90. So when GR is equal to 2 times R, that means instead of this I can write R plus 2R is equal to 90 degrees. So I'll get R is equal to 30 degrees. Simple. When R is equal to 30 degrees, I is also equal to 30 degrees. Yes or no? So what is the answer? 30 degrees is the answer. Clear? Able to understand? Yes. Let us move on to the next question. Let us move on to the next question. So far we have discussed about tested basics questions. Let us now move ahead to discuss the knowledge based questions. Okay. So here first question is write the laws of reflection. Very clear. What are the laws of reflection? The first one is angle of incidence is equal to the angle of reflection. Okay. The second one is the incident ray, the reflected ray, and the normal at the point of incidence all will lie in the same plane. Clear? These two will form the laws of reflection. This is quite easy. This is just recalling of whatever you have learned earlier. Okay. Let us move on to the next question. What is the principal focus of a concave mirror? What do you mean by principal focus? The point where a parallel beam of incident light parallel to the principal axis after reflection will pass through that point. Okay. So the point is the one on the principal axis at which all the reflected rays will meet when parallel beam of light parallel to the principal axis falls on the concave mirror is called principal focus. They are getting reflected from the mirror. So they pass through this particular principal focus. Clear? So that is the point. How do you define it? Clear? Okay. Let us move on to the next question. Write the mirror formula and explain the terms. Simple. What is the mirror formula? 1 by f is equal to 1 by v plus 1 by u. F is the focal length, u is the object distance, and v is the image distance. Only 3 terms, that's it. Nothing to worry. Clear? Let us move on to the next question. Which of the phenomena can be explained by considering light as a wave? In this particular chapter, we are dealing with the reflection of light by taking the light rays. Okay. But there are certain phenomena related to light which will be explained based on the wave nature only. So let us see some of them. Okay. Interference, diffraction, polarization. These 3 phenomena can be explained only by the wave nature of the light. Clear? Let us move on to the next question. Write the wavelength range of visible light. What do you mean by wavelength range of visible light? When you're talking about the light as a wave, V is equal to n lambda. So lambda is equal to wavelength. Okay. Frequency will change for the white light. Okay. So when you consider the wavelength, it is from 400 nanometer to 700 nanometer. 1 nanometer, as we told earlier, it is 10 power minus 9 meter. Clear? So far we have discussed about the knowledge based questions. Let us now move ahead to discuss some understanding based questions. The first question is here. See, what is the angle of incidence of a light ray passing through the normal to the reflecting surface? What do you mean by angle of incidence? Angle of incidence is nothing but the angle between the incident ray and the normal. Okay. Here what is given? What is the angle of incidence of a light ray passing through the normal to the reflecting surface? What is normal? 90 degrees. An imaginary line passing 90 degrees to the point of incidence on the reflecting surface. Okay. As per the question, it is given that the light ray is incident normally. Means what? It is coming along the normal, so it will retrace its path. Okay. So what would be the angle of incidence? 0. So is the angle of reflection also, because when angle of incidence is 0, angle of reflection is also 0. That is the reason the light ray would be retracing its path. Clear? So if the angle of incidence of a light ray passes through the normal, then the angle of incidence is 0. That is the answer. Hope we are clear with it. Let us now move on to the next question. Complete the ray diagram given below. So this is the ray diagram given. You can see what type of mirror is this. Is it a convex or concave? You can see very clearly on the right side portion of the mirror, it is silver coated. So left side should be reflecting. And what is the left side? Is it bulged in or bulged out? Bulged in, right? So it's a concave mirror. Very clear. And where is the object lying? See, the object is lying here. This is the object. Between the focus and the pole. Now try to recall the ray diagrams. Okay, whatever we have discussed for the ray diagrams for the concave mirror. light ray is going parallel to the principal axis over here. After reflection, it will go through the focus. Okay, and here this light ray is directed along the line joining the center of curvature to the particular point on the object. So it will get retraced back because it is passing through the center of curvature. Let us draw these two lines. One is this one, where it is after reflection passing along the center of curvature. The second one is this. So now observe these two light rays. Are they convergent or divergent? Obviously they are divergent, right? If you see, the distance between these two is increasing when they are progressing in the forward direction. So what you need to do? You need to reproduce them, produce them back behind the mirror. Okay, this light ray will go this way, the second one will go this way. So now here you have a point where these two light rays are incident. At this particular point is a one where you will get the image. Clear? So this is the point under consideration where you will get the image. Right? So this completes the ray diagram. And what is the nature of the image? Obviously it is virtual, erect and magnified because the object is placed between F and P. Clear? Let us move on to the next question. Find the image distance and nature of the image produced by a concave mirror. Try to understand this is a concave mirror. Of focal length 20 centimeters. So this is the focal length. When an object is placed at 60 centimeters away, so this is the object distance, so U, from the pole of the mirror. So from the given information I can write U is equal to 60 centimeter. Okay, fine. By concave mirror, so whether it is a mirror is a concave or a convex, object distance is always negative, applying the sign convention. Clear? Focal length 20 centimeters, so F is equal to 20 centimeter. Now you tell me whether it is positive or negative. Concave mirror, right? So it is negative only. You will measure from the pole towards the focus, principal focus. So it is negative. Clear? Now what is asking? Nature, find the image distance and nature of the image. First of all, try to find out the image distance. That is nothing but V. Image distance V is equal to what? We need to find out that. What is the relation clubbing all the three physical quantities over here? Very clear, no? It is 1 by F is equal to 1 by V plus 1 by U. Okay, now substitute. We need to find out what is V, 1 by V. 1 by V is equal to what? 1 by F minus 1 by U. So I'll simplify the right hand side. I'll get it as U minus F divided by UF. Okay, so from this I'll get V is equal to UF divided by U minus F. What is U into F? Minus 60 into minus 20. Minus into minus becomes plus, right? So 1200. 60 into 20 is 1200. Okay. Divided by U minus F. U is already minus 60. Minus 60 minus minus 20. So I'll get it here. Minus 60 minus focal length is 20. Okay. After substituting the U and F values in the numerator, I got it as plus 1200. But in the denominator, let us see how much I am getting. This is 1200 divided by minus 60 plus 20. Minus 60 plus 20 is minus 40. So this is minus 30. And what is the unit? Centimeter. Now I say minus 30 centimeter. What do you mean by minus over here? Simple. The image is real inverted. Okay. And as far as distance is considered, this is 60 centimeter, this is 30 centimeter. Okay. So V is less than U magnitude wise. So what about magnification? Magnification will be less than 1. Okay, M is equal to nature of the image. Nature of the image, how can you predict with this? Minus 30 centimeter means this is also coming as minus. That means it is a real image. So I'll say it is a real image. When it is real, it will be definitely inverted. Okay, and then you compare the focal length and the object distance over here. Focal length is equal to 20 centimeter. Object distance is equal to 60 centimeter. Okay, ignoring the negative signs which you have placed it using the sign conventions. Now, when you consider that object distance is greater than the radius of curvature, f is equal to minus 20 means what is the radius of curvature? 40, right? Minus 20 is, so minus 40 will be the radius of curvature. So ignoring the negative sign, that is 40. Okay, but object is lying at a 60 centimeter distance from the pole. That means object distance is greater than the radius of curvature. So what would be the nature of the image formed? Try to recollect the ray diagrams. Real, inverted, and yes, exactly, it is diminished. Smaller in size. You are getting a smaller value of V. That is also an indication. Okay. So distance, nature of the image. I can also say because V is less than U, the object is diminished. Magnification is less. Clear? It is not even equal to 1. It is less than 1. Clear? Let us move on to the next question. An object is placed in front of a spherical mirror at a distance of 15 cm from it. A real image is formed at 30 cm from it. Arrange the following steps in the proper sequence to determine the focal length of the mirror. Okay. When you say an object is placed in front of a spherical mirror at a distance of 15 cm, he's telling spherical mirror, not concave or convex. We are not sure about it from the first statement. A real image is formed. Now clarity is there. When do you get a real image? Only by concave mirrors, right? Not by convex. Now what is a spherical mirror is clear from the second statement. A real image is formed at 30 centimeter from it. So object distance is less than the image distance. Okay. Arrange the following steps in the proper sequence to determine the focal length of the mirror. So how do you get the focal length? First you have identified what is the nature of the mirror. Okay. Then you got the values of U and V. Then what will you do? You substitute in the mirror formula to get the value of the focal length. Substitute and simplify it. This is the methodology what we follow, right? Let us observe the statements what are given. Substitute the value of U and V in this. Second statement, obtain the value of the focal length. Okay. Third statement, decide whether the mirror is convex or concave by the nature of the image given. Okay. Assign proper signs to U and V by using the sign convention. Clear? So now what will you do? You will go with the first one is decide. So this is the first one. Okay. You'll say this is the first one. So C is 1. Next what will you do? Assign. Okay. Proper values, sign values to the U and by using the sign convention. Once you get the convex and concave, then you will be able to get the sign convention. So this is second step. Third step, Substitute these things in this. Finally, fourth is this. Okay, so let us see the options now. D A C B, A B C D, B A C D, C D A B. So what is the correct option? First one is C, second is D, starting with C, which is the one. So fourth is the answer. So C, this is the right answer. C, D, A and B. So this is the correct option. Clear? Let us now move on to the next question. Match the entries in column A with the appropriate ones in column B. And he has given here. Okay. A to D, B to C, C to A, D to B. So like that we have the options. Now we need to identify which is the correct option out of the 4. Now let us try to check the first one in column A, real magnified image. Okay, where do you get a real magnified image? Is it a convex lens? Sorry, concave mirror, or is it a convex mirror? Obviously it is a concave mirror. So need to check on the options over here. See, first one, object placed at a distance less than the focal length of a concave mirror. No. Object placed at a distance less than infinite and in front of a convex mirror. So convex mirror, it is not a convex mirror. Let us see. Object placed at a distance less than the radius of curvature of a concave mirror. Yes. So I'll get it as C over here. Next, real and diminished image. When you look at a diminished image, object is placed at a distance greater than the radius of curvature of a concave mirror. Then you will get a diminished and a real image. So next one is the B, D. So this is the one corresponding there. Now virtual magnified image. When do you get virtual magnified image? Virtual magnified image is obtained by a concave mirror only. That too in one condition. What is the condition? We need to place the object between F and P. Between the focus, principal focus and the pole. So where is that option? Less than the focal length of a concave mirror. So next is A over here. So I'll get A over here. And then finally, what is remaining? B. So virtual diminished image is B. So C, D, A, B. Where is the option? C, D, A, B. So third one. Third option is the right option. Clear? Let us move on to the next set of questions, that is application based questions. So here we have in this particular question a rod of length 30 centimeter and diameter 4 centimeter is placed in front of the concave mirror of focal length 10 centimeter as shown in the figure. Find the difference in the diameter of the far end and the near end of the image of the rod. See, in this particular image, I have a concave mirror, that is clear. Focal length is given as 10 centimeter. Okay. This is 30 centimeter. Length is 30 centimeter. I'm not writing the units. Okay. 30 centimeter. Diameter is given as 4 centimeter. Let it be like that. Okay. This is 4 centimeter. In front of a concave mirror of focal length 10. Okay. This is 30 centimeter. Find the difference in the diameter of the far end. So this end, let me note down the two ends of the rod over here. Let me write it as A and B. Okay. The end B of the rod is located at point C. Okay. So where does the image of B form? At the same place. Let me write it as B dash. Okay. Because we know that when the object distance is equal to the image distance, it is possible in the case of concave mirror only when the object is placed at the center of curvature. So B is at center of curvature. So if B dash indicates the image of B part of the rod, then I'll get B dash here itself. Now A is away from the mirror. Okay, the point A of the rod is lying beyond the center of curvature. So its corresponding image will be formed somewhere between C and F. Okay, so if I have, I'll get the shape of the rod like this and somewhere here like this. This will be a diminished one. This is the nature of the image formed. Okay, this is a uniform thickness, but the image will not have uniform thickness. Okay, because different positions of the rod are at different locations from the mirror. Okay, now this is a real image. No doubt it is a real image. So now what is happening? At this end, it is a 4 centimeter only. Okay, 4. But here, what is that diameter? I don't know. If I know the position of say A dash here, because now I know what is the position of A. How do I know A? The length is 30 and the location of B from the mirror is 10 plus 10, 20. Okay, so 20 plus 30, totally 50. So let me write for A. For the point A, object distance U is equal to how much? Now we calculated, right? So 50 centimeter. What is the focal length of a concave mirror? F is equal to 10 centimeter. That is also known for us. Applying the sign convention, we'll get negative for these two. So I wanted to know what is the image distance. So 1 by F is equal to 1 by V plus 1 by U. Okay, so I will get it as 1 by V is equal to 1 by F minus 1 by U. From this, I will get this as 1 by V is equal to U minus F divided by UF. So I'll get V is equal to UF divided by U minus F. Once you get this, now substitute the values. What is the value of U? Minus 50. So I'm writing minus 50 over here. Into F is minus 10. Clear. Divided by U minus F. U is how much? Minus 50 minus 10. Now simplify. Minus into minus is plus. I'll get it as 500 over here. Divided by, in the denominator, what I'm going to get? Minus 50 plus 10. So it is minus 40. So minus 40. So it is nothing but minus 25 divided by 2 centimeter. Minus 12.5. Okay. So that is the image distance. But are we interested in that? No. What we want? Magnification. Because the diameter at the point A is 4 centimeter. I want to know what is the diameter at the point A dash. So for that I need to know what is the magnification. Magnification is equal to minus V by U. So what is minus of V is minus 25 divided by 2 divided by U is minus 50. Okay. So the same thing I'll get it as height of the image divided by height of the object. Okay. So this minus and minus gets cancelled. Fine. I'll get this as HI divided by HO will be equal to 25 divided by this 2 will come to the denominator. Okay, it will become 100. So it is nothing but 1 by 4. So implies height of the image here is equal to what? 1/4 of the height of the object. That means height of the object is nothing but diameter at the end A, that is 4 centimeters. So that is nothing but, if I substitute HO is equal to 4, I will get this as 1 centimeter. Okay. What is the diameter at the end B? It is nothing but 4. At the end A, it is A dash, it is 1 centimeter. So what is asking? Difference in the diameter of the far end and the near end. Far end is B dash, near end is A dash. So I can write say delta D difference in the diameter is equal to diameter at B dash minus diameter at A dash. Diameter at B dash is nothing but 4 centimeter. At A dash it is 1 centimeter. So I'll get it as 3 centimeter. This is the answer. Appears to be a little bit difficult, but once you try to begin the solution, it is as simple as that. Clear? Let us move on to the next question. Vishant is playing with a concave mirror and convex lens of focal lengths 20 cm each. He placed these two mirrors 10 cm away from an object separately and found the distance between the images produced by these two mirrors. What is the value of it? And find the ratio of the magnification of the concave to the convex mirror. You can see very clearly over here, playing with concave and convex mirrors of focal lengths 20 cm each. Let us say if concave CV, that is 20 cm minus 20 cm, applying the sign conventions. So FCX convex, I write this way, this is nothing but plus 20 cm each. He placed these two mirrors 10 cm away from an object separately. So for both the cases, U is equal to 10 cm. Here also U is equal to 10 cm. But the object distance will be negative in both the cases. Clear? And he found the distance between the images produced by these two mirrors. Okay. What is the value of it? That means you need to find out the distance or image distance in the first case here, say Vx. Sorry, Vv. Let me write it as Vv. Image distance in the case of concave mirror, and here let me write it as Vx. Image distance in the case of a convex mirror. Okay. So, and he found the difference between and found the distance between the images produced by these two mirrors. What is the value of it? That means you need to find the difference in the value of Vv and Vx. Second thing, what is the find the ratio of the magnification of the concave mirror to the convex mirror. So magnification in the case of a concave mirror and magnification in the case of a convex mirror. You want the ratio of these two. First, let us focus on how to get the value of the V. That means going by the mirror formula, 1 by f is equal to 1 by V plus 1 by U. Okay. So from this I will be able to get this 1 by V as 1 by f minus 1 by U. So it's equal to U minus f by UF. So V is equal to what? UF divided by U minus F. I am showing the derivation so that this particular part you will be able to do it on your own. So even you can, if you remember this formula, you can straight away write this one also, no issues in it. So let me write in this particular case VV is equal to, how do I get UF? That means minus 10 into minus 20. So it is 200 divided by U minus F. Minus 10 minus minus 20. Okay. Minus 10 minus minus 20 is minus 10 plus 20. Minus 10 plus 20 is what? Plus 10. So it is plus 10. Okay. So what I am getting here? This is 20. You can see very clearly focal length is negative, object distance is negative, but I have got the image distance to be positive. Why? It is a virtual image. Simple. The object is placed between the pole and the focus. So we'll be getting magnified virtual image. Now in this case, let us go with the same thing. Let me write it as Vx is equal to same formula, UF by U minus F. What is UF? UF is nothing but 20 into minus 10. Sorry, minus 10 into 20. So it is minus 200. Minus 200 divided by U minus F. U minus F. So minus 10 minus 20. Minus 10 minus 20 is minus 30. So minus 30. So it will become 20 divided by 3. This is also positive. This is 20. This is 20 divided by 3. So if you find out the difference, that is delta V, okay, I'll get it as 20 minus 20 divided by 3. So I'll get it as 20 into 1 minus 1 by 3. 1 minus 1 by 3 is nothing but 2 by 3. 2 by 3 into 20 is 40 by 3. So 40 by 3 centimeter, that is the difference. That is the distance between the images produced by these two mirrors. That is one thing. Second thing, we need to find out what is the value of M, magnification. So let me find out first what is MV. How do we get the magnification? M is equal to minus V divided by U. That is a formula. So if I take MV minus of, what is V over here? 20 divided by, what is U? Minus 10. So minus 10. So this is nothing but 2. Mx if I consider, I'll get this as same formula again. Minus V. So minus of, what is V? V is 20 by 3. 20 divided by 3. And what is U? U is again minus 10. So it will become equal to 2 by 3. Okay. If you simplify, this minus and minus will get cancelled. Okay. This 3 will come in the denominator. It will become 20 divided by 30. So it will become 2 by 3. Clear? Now, if I consider the ratio of MV divided by MX. Okay. This is 2 divided by 2 by 3. If I consider, I'll get it as 3:1. 3 by 1. Is this clear? Let us now move on to the next question. Find the focal length of the convex mirror in the given below figure. If the focal length of the concave mirror is 10 cm and the position of the images formed by both mirrors for a given object AB coincides. If you consider here the distance between the two mirrors is taken as 25 cm. This information is given. Focal length of the concave mirror is 10 cm. That means from here to here, this distance, if I take this as P, F to P, here the distance is 10 cm. And important information given here is that position of images formed by both the mirrors for the object AB coincides. Implies whatever the position of the image formed by the concave mirror is there, at the same position we have the image for the convex mirror also. Let us try to find out the position of the position of the image formed by the concave mirror. Okay, using the mirror formula, 1 by F is equal to 1 by V plus 1 by U. If you take from this, I will get V is equal to UF divided by U minus F. This is for the concave mirror, whatever I am trying to find out. Okay, so I will substitute the values. Now, what is the object distance over here? 15 cm. I'll take it as minus 15 because I need to use the sign convention. Into focal length is again 10 cm, so minus 10 divided by U minus F. So U is minus 15 minus 10. Okay. Simply you can calculate here. Minus 15 into minus 10 is plus 150 divided by minus 15 plus 10. So it is 150 divided by, this is minus 5. Okay, this is minus 30. That means from this particular pole, the image due to the concave mirror is formed at a distance of 30 centimeter on the same side as that of the object, and inverted and real and magnified. Fine. That means if at all this is the position where the image is formed, from here to here it is 30 centimeter. Already from this distance is 25 centimeter between the two mirrors. So what is the balance? This distance is now only 5 centimeter. And as per the given question, the image due to the convex mirror also forms here at the same point. Now that means for the convex mirror, if I consider, I got the two things. One is the focal length is what you need to find out, but you are given the object distance. How much is the object distance? This distance is the object distance. 25 minus 15. So it is 10. So I'll take it as minus 10. Minus 10 centimeter is the object distance denoted by U. Okay. And V is also known now. It is 5 centimeter. I'll take it as plus 5 centimeter as per the sign convention. So I'll use the same mirror formula. 1 by F is equal to 1 by V plus 1 by U. From that I'll get F is equal to UV divided by U plus V. Substitute the values. Minus 10 into 5 divided by minus 10 plus 5. So this is minus 50 divided by minus 5. I'll get it as 10 centimeter. That is the focal length of the convex mirror. Hope this is clear to you. Let us see the next question. A square is drawn in front of a concave mirror as shown in the figure. Find the area of the image of the square if the focal length of the mirror is 10 centimeter. Okay, so if you see very clearly here, I have the, let us assume the P is the pole of the mirror over here. Okay, what is given here? Focal length is 10 centimeter, that's it, that is given. If you see the object here, this object is placed along the axial line. Okay, the square is placed along the axial line. AB part of the square is away from the mirror compared to the CD part. Okay, and both the parts AB as well as CD part are beyond the center of curvature. Okay, so what is happening? The image for both these parts will be formed within the distance C and F. Okay, so I'll get the image over here between these 2 points. Fine, but now if you consider carefully, where is the image of AB formed and where is the image of CD formed? As AB is far away compared to CD, the image of AB will be closer to the pole of the mirror. So let me draw a structure like this. So assuming that this is the principal axis and here is the P, I will get the image of AB over here. So let me point A dash is the image of A and B dash is the image of B. Okay, this will be formed between C and F. So somewhere here I will have the F. So forget about it. Next, I will have the CD part of the image somewhere formed here. So D is along the principal axis. So D dash will be formed over here and C dash will be formed over here. So now if I join this C dash and B dash, what is the shape I am going to get? It is a trapezium. And what is asked here? Find the area of the image of the square. So image of the square is not of the shape of a square. It is of the trapezium. Okay. So if I want the area of this particular trapezium, I'll get this area as, okay, half into sum of the parallel sides, that is C dash D dash plus A dash B dash into, okay, distance between the two parallel sides, that is nothing but D dash A dash. And d dash a dash I don't know directly. D dash is the image of CD, or d dash c dash is the image of CD. So if I want to know d dash a dash, I need to measure d dash and a dash from P, so that the same thing now I can write it as, okay, this one I can write it as d dash to P minus a dash to P. This d dash P and a dash P are nothing but the image distances. Okay, so now I know the mirror formula, 1 by F is equal to 1 by V plus 1 by U. From this, I'm going to get V is equal to UF divided by U minus F. That is one thing. Next is, if at all I wanted to know the length A, D dash C dash or A dash B dash, this is the size of the image. So I need to get the magnification for that. So I know magnification M is equal to HI divided by HO. The same thing is minus V by U. So I'll get in from this as HI is equal to minus HO into V divided by U. Now if I take the value of V by U from this expression over here, what I'm going to get, it is, this is nothing but HI is equal to HO into, if I multiply minus into the right hand side of this expression over here, I'll get it as F by F minus U. So F by F minus U. So directly I'll be able to get this. Let us now work out for C dash D dash. This will be equal to what? HO. What is HO? This is the object size, that is 10 centimeter. CD 10 centimeter into F. What is the focal length of the mirror? 10 centimeters. So into minus 10 divided by, okay, F minus U. F is again minus 10. Minus 10 minus U. What is this U? Distance of the object. DC object, distance from pole. That is 30 centimeter. Right? So minus 30. I'll get this as minus 100 divided by how much? Minus 10 minus of minus 30, it is 30 minus 10, 20. So I'll get it as minus 5. Don't worry about the negative sign. It is indicating that it is an inverted image and formed below. Now similarly, I wanted to find out what is A dash B dash. Same logic. So this is nothing but HO into F. What is HO? Height of the object, it again 10 into minus 10. That will not change in the numerator. Okay, F minus U here. So F also is minus 10. That is also not changing, but now this U will change. What is U? Distance of AB from the pole. So 30 plus 10, this is 40. So minus 40 going by the sign convention. So it will get it as minus 100 divided by, okay, 40 minus 10 is 30. So it is 30. So I'll get it as minus 10 by 3. Okay. So AB, CD, C dash D dash I got it, and A dash B dash also I got it. So in the expression for the area, these 2 points I got. Now I need to find out what is D dash P and A dash P. So D dash P, if I wanted to find out, I need to use this expression for V. Okay. So V D dash. Let us find out. UF. What is U? Object distance. For what? D. So it is 30 minus 30 into minus 10 UF divided by U minus F. That means minus 30 minus minus 10. So it will become 300 divided by, this is minus 30 plus 10. So minus 20. This is nothing but minus 15 centimeter. Don't bother about the negative sign. It is indicating that it is an inverted image, a real inverted and diminished image. Okay. So now similarly, that means this is nothing but your D dash P. Okay. Similarly, we'll consider A dash P. A dash P is nothing but V A dash. Let me write over here. So it is again the same formula, UF divided by U minus F. But what is U over here? It is minus 30 minus 10. So minus 40 in going with the sign convention, into minus 10 divided by U minus F. So minus 40 minus 10. So I'll get it as what? 400 divided by, okay. So this is minus 30. So I'll get it as minus 40 divided by 3 centimeter. So if I wanted to calculate what is D dash P minus A dash P, D dash P is minus 15. I mean, basically magnitude wise, if you consider 15, this is 40 by 3. So now you try to get the area. Okay. Area is equal to whatever the required area, half into C dash D dash. What is this? 5. Okay. 5 plus, okay, A dash B dash. What is A dash B dash? 10 by 3. 10 by 3 into, okay, and D dash P. D dash P is image distance of dish. That is 15. And minus 40 by 3. Now if you simplify this, I am going to get it as half into, this is 15 plus 5, 25 by 3. Okay. And this is 45 minus 40 is 5 divided by 3. So basically I am going to get it as 125 divided by 18. Okay. So centimeter square. Is this clear? Let us see the next question. An object of height 10 centimeter is placed in front of a convex mirror. Find the height of the image if the object distance is equal to 1/4 of radius of curvature of the mirror. What is given here? Height of the object is given 10 centimeter. Mirror is convex mirror. Find the height of the image. We need to find out what is Hi is equal to how much. And what is given? U is equal to R by 2. Sorry, R by 4. Not R by 2, R by 4. So R by 4. This is equal to F by 2. So applying the sign conventions, I will get it as minus. I'll go with the mirror formula. 1 by F is equal to 1 by V plus 1 by U. Now implies 1 by V is equal to 1 by F minus 1 by U. So if I take this way, 1 by F minus of U is minus F by 2, minus F divided by 2. So this will become minus and minus plus. So it will become 1 by F plus 2 by F. So it is nothing but 3 by F. Okay. So this means that V is equal to F divided by 3. U is equal to F divided by 2. V is equal to F divided by 3. I got it as positive. Okay. So indicating that the image distance is positive in the sense it is a convex mirror. Condition is satisfied, right? What is he asking? Image height. So M magnification is equal to Hi divided by Ho, which is nothing but minus V by U. Now equate these two. The right side, these two expressions you equate. So what I am going to get? Hi is equal to minus V by U into Ho. This is given 10 centimeter. But what is V? V is equal to F divided by 3. F by 3 divided by what is U? Minus F by 2. Minus is there here. Minus F by 2. this minus is for this minus over here this way, and u I know it is minus f by 2 into 10. So if I simplify it, I'll be getting it as 2 by 3 into 10, which is nothing but 20 divided by 3. Okay, that is 6.6 bar centimeter. I can write it as, okay, 6.67 centimeter I can take it. Okay. Now, the height of the object is 10 centimeter, whereas the height of the image is 6.7 centimeter. So, the height of the image is less than the height of the object. So, the image formed is diminished. Okay. This is how you will be able to solve the questions. Hope you have validated all the questions as far as the skill builder exercises are there. Okay. Hope you have enjoyed the application based questions, solving them. Okay. So, thank you for watching. Have a good day.